Ever wished you had a time machine? Like to see how planets evolve over, well, billions of years.
Yeah.
Today's deep dive, it's kind of like that. We're headed to a star system, HD 11300067, that astronomers thought was ancient.
Oh.
105 light years away. 6 exoplanets, all in perfect orbital sync, a cosmic ballet rehearsed for eons. Except, not so much. Turns out this system's practically a cosmic toddler.
A young system with that much harmony, that's unusual, isn't it?
It throws a wrench into a lot of assumptions. HD 100067 was supposed to be 8 billion years old.
8 billion.
Now they're saying more like 2.5 billion?
No, what, like a third its original age? That's a massive difference.
Huge EE. And it all started with a kind of basic method. Scientists used the star's brightness and temperature to estimate its age, like a cosmic glance.
I see, so they relied on its outward appearance.
Exactly. Problem is, that method, not so reliable for stars smaller than our sun.
Yeah.
Guess what? HD 110067 is one of those smaller guys.
So the initial estimate, way off. What tipped them off? What made them realize something wasn't adding up at the age?
Well, they started digging deeper, became cosmic detectives, looking for more clues. First, they checked something called ionized calcium emissions. Younger stars, more active, more energetic. That makes calcium in their atmosphere glow in a specific way. HD 110067. Way stronger calcium emissions than you'd expect for an 8 billion-year-old star.
A bit too lively for its supposed age. So the first hint, it might be more of a youngster than a seasoned veteran.
Precisely. Second clue, the spin. Stars, over time, they slow their rotation, like a spinning top. HD 101067. Spinning much faster than expected. Rotates once every 20 Earth days.
That's faster than our sun, even though our sun's way younger.
Way faster. So these two things, the calcium and the spin, they said, whoa, wait a minute.
Had to reevaluate.
They compared HD 111067 to other stars, similar but with more reliable ages, like a cosmic reference guide.
And the verdict, how young is this star system really?
Instead of 8 billion, just 2.5, give or take 800 million years.
Still a long time, but that changes things, especially when you consider those 6 planets orbiting it. Perfectly in sync.
Tidally locked, too. Every one of them. One side always facing the star, like our moon with Earth. Initially, scientists figured that whole setup, the sync, the locking, took billions of years to develop. But if a star is younger...
It happened much faster than we thought.
Exactly. Throws a wrench into everything. Now we got to ask, what does this mean for life on those planets? We're talking about a young star, probably way more active, more radiation.
Yeah. A much harsher environment.
A trade-off, right?
Yeah.
Less time for life to evolve, but also a lot more to deal with. And remember, all 6 planets we've found so far.
Yeah.
They're super close to the star.
So they're probably scorching hot, like furnaces.
Not exactly ideal for life as we know it.
There's a catch. And it gets really interesting. See, the planets we've found, they're all close in, orbiting fast. That's what our current methods are good at detecting.
So further out, there could be more planets we just haven't seen yet.
Exactly. Ones with longer orbits.
Yeah.
And the fact that the star system is so young, that makes those potential outer planets even more interesting.
More interesting. How so? I'm not sure I follow that.
Well, think about how planets form. Gas, dust, all swirling around a young star, right?
Right.
If HD 100067 is only 2.5 billion years old, those outer planets, if they exist, would be pretty young too.
Still forming, still evolving, not settled down yet.
Exactly. Not like planets have been around for billions of years, nice and stable. These would be dynamic, volatile.
Maybe even still going through major geological shifts. Volcanoes, oceans forming.
Could be. Now, back to life for a second. We've said those inner planets are probably too hot, plus all that radiation from a young star.
Right.
But are we being too Earth-centric? Maybe there's life out there that doesn't mind a little radiation.
Life that could actually thrive in those conditions.
Yeah.
It's happened here, right? Life on Earth is surprisingly tough.
Exactly. We tend to assume life needs what we need. But what if there are organisms out there that tolerate, even need that kind of radiation?
Or love those super hot volcanic environments.
It makes you wonder if our search for life is too narrow. Like, are we only looking for another Earth?
Good point. So, about HD 117067 itself, is it a good target for, say, a space mission, a closer look?
Oh, absolutely. It's relatively close, and that whole system, confirmed planets, potential ones, it's a gold mine. high on the list for future observations.
What kind of missions, specifically, are there telescopes that would be good for this?
Well, the James Webb Space Telescope, it can study exoplanet atmospheres, look for molecules that might hint at life.
Even those super hot inner planets?
Even those, it's not about habitability there, but about the information, what those atmospheres tell us about the system, how planets form around young stars.
So even those furnace-like planets could be useful.
Exactly. And for finding those outer planets, new ground-based telescopes are coming online. They're designed to be super sensitive.
Sensitive to what exactly?
To tiny wobbles. See, when a planet orbits a star, its gravity makes the star wobble a little bit. These new telescopes can detect those wobbles even from really distant planets.
So they might be able to pick up those outer planets around HD 111067.
That's the hope. We might be on the verge of a whole new wave of discoveries, finding fainter planets, seeing deeper into these systems.
Exciting times. Okay, we've covered a lot. The initial age estimate being wrong, potential undiscovered planets, even life as we don't know it. Quick recap. Key takeaways from this deep dive.
Sure. We started with HD 113067, supposedly 8 billion years old, planets all in sync. Figured it took eons to form.
Right, like a perfectly rehearsed cosmic ballet.
Then through some stellar detective work, found out it's way younger, only 2.5 billion years old. Changes everything.
Throws a wrench into our understanding of how these systems evolve.
Means that whole ordered system might have formed a lot faster than we thought. And then there's the question of life. What kind might exist on those planets given the conditions?
And don't forget those possible outer planets, cooler, maybe even in the habitable zone.
Right, the sweet spot where liquid water could exist. We just haven't seen them yet.
A star system more complex and dynamic than we initially thought. Those hypothetical outer planets. The ones that could be in the habitable zone. It really makes you wonder, what would they be like?
Ah, the habitable zone, the sweet spot, right. Where it's not too hot, not too cold. Liquid water could exist.
Exactly. And we think liquid water is pretty crucial for life as we know it. So imagine there are planets orbiting HD 910067 in that zone. What might they be like?
Well, we got to remember, this is a young system. Even if those planets are in the habitable zone, they might be very different from Earth.
Different how?
Think more.
All right.
Active, volcanically active, maybe oceans that are still forming, landscapes constantly changing.
Wow, that's a pretty wild picture. So how do we find these planets? And could we actually see what their surfaces are like?
Two things. Remember those new telescopes I mentioned? The ones super sensitive to wobble?
Yeah, the ones that can detect the gravitational tug of a planet on its star.
Right. Those could help us find those outer planets, and once we know they're there, well, that's where the James Webb Space Telescope comes in.
The James Webb. It can study exoplanet atmospheres, right?
It can. Analyze the light passing through the atmosphere, see what gets absorbed. That tells us what gases are there, what the climate might be like.
Could it tell us if there's liquid water on the surface?
Potentially, yeah. And one of the key things we'd look for are biosignatures.
Biosignatures. What are those?
Chemical compounds in the atmosphere that are produced by living organisms. Think of oxygen on Earth.
Ah, from plants and photosynthesis. So if we saw a lot of oxygen in the atmosphere of one of HD 1136-7's planets?
It would be a very strong hint. Not definitive proof, but very intriguing.
So just being in the habitable zone isn't enough. We need to look for these chemical clues, too.
Right. And even then, we got to be careful. There might be other explanations for certain gases. We can't jump to conclusions.
It's like being a detective, but on a cosmic scale.
Exactly.
HD 1136-7. It's going to keep us busy for a while, huh?
Oh, yeah. Years to come. Lots more to learn.
Well, this deep dive has been fascinating. We started with this star system, thought it was ancient, had it all figured out.
And it turned out to be way more complex than we thought.
Way more.
Yeah.
It really makes you realize how much we still don't know about the universe. Every answer just leads to more questions.
That's science for you. The quest for knowledge never ends.
I love that. So, dear listener, thanks for joining us on this deep dive. One last thought for you. Imagine someday we DO find those outer planets around HD 111067. What would it be like to stand on a world orbiting a young, energetic star? A world that's still forming. Keep looking up, keep asking questions, and never stop exploring.